empezamos con otra clase de clases. La idea es poder comprender bien cómo son las clases, cómo funcionan, su definición, sus usos, sus características para poderlas usar bien a futuro. Entonces, pues vamos a darle.
Separate copies of their instance variable in the variable. So what happens, that party, or that in J, 1, and then we're going to call J party, that turns that into a 1, and then S party will cause this to be a 2. Okay, so what happens is we have now two objects, one in the variable S and one in the variable J, and they have separate copies of their instance variables. These are the instance variables or the object fields or whatever, but they're their full new is a copy of this. And so this is how it's going to look, right? As it
Nosotros vimos ayer que eran constructor, ¿no? Constructor is a special method named init that gets called with underscore at this time create an object.
runs down here, as it runs down here, when this is called, it makes one instance and stores that in the variable x. And there's a variable x in there, there's a name in there, there's an init method in party, and that's all in here, right? All that stuff is in here. And now we say, let's make, and that's going to have Sally in there. All right, Sally in there. And then we're going to do another constructor, and so it's going to make a whole new thing, and it's going to store that in J, and this one's going to have Jim in it. S party, then this turns into a 1, and then we're going to call J party. That turns that into a 1, and then S party will cause this to be a 2. Okay, and so what happens is we have now two objects, one in the variable S and one in the variable J, and they have separate copies of their instance variables. These are the instance variables or the object fields or whatever, but they're the variables. But the key is that every time we do our new construction, it duplicates this, and there's another copy of it. So there's an X within S. So S dot X is this variable, and J dot X is that variable. Okay? So the next thing we'll talk about is inheritance, and that's the idea of taking one class and extending it to make something new.
Okay, that's the definition. Okay, is the idea of taking one class and extending it to make something new. Okay.
So the last topic we'll talk about here in object orientation is the notion of inheritance. And this is a form of code reuse, and it's one of the more advanced aspects of object-oriented programming. So just kind of understand what it is at a high level, and then you know where to come back to when you need to learn a bit more about inheritance. So the idea is, instead of making a new class from scratch, we actually make a new class by starting with an existing class. We are extending it, or another word for this is subclassing. And it's sort of a...
Okay. When we make a new class, we can reuse an existing class and inherit all the capabilities of an existing class, and then add our own little bit to make our new class. Another form of store and reuse. Write once, reuse many times. The new class shall has all capabilities of all class parent, and then some more. Class shall has all capability of all class parent, and then some more. Okay, taking the class and extending it to make a new. But we can reuse an existing class and inherit it. We can reuse an existing class and inherit all the capabilities of an existing class, and then add our own little bit to make our new class.
A situation where you're like, I've got this code and I've got this data and I just need to add a few things to it and then I'll have a whole new thing. And as you design objects and what we call object hierarchies, you often do this. And it's a form of sort of real clever code reuse. But again, don't necessarily think that you're supposed to know when to use this or why to use this. It's right now, it's just terminology, okay? Just terminology. We have what call these as parent-child relationships. The original class is called a parent, and the new class is called the child class. So subclasses are another word for this. You have a class and then you subclass it.
Subclasses
I
are
think
more.
extending and inheriting and parent-child are probably better ways of expressing it than subclassing. So here's a bit of code. Let's take a look at this. This code's unchanged. It's the party animal code that we've been saying all along. It's the one that we construct and put a name in. And now what we're going to do is extend it. And so you'll notice that this code down here is the part that's doing the extending. So we're making a new class, football fan, and by putting in parentheses before the colon, party animal, that says football fan inherits everything that is party animal, meaning the X, the name, the init, the party, all those methods and data are sitting there. And now we're going to add a new variable. So football fan has, in addition to all those other variables, has points, and it has a touchdown method. And, self points is added, we add 7 to the points, and then we call the party. And that does that. So this is calling this method because football fan includes X, name, and party, and init, and everything, and all this stuff, this constructor. So this football fan is really an amalgamation of all these things together. Party animal is just this stuff, right? And so we still have 2 classes. We don't just have one. We didn't erase the party animal class. And so we take a look at the code that we can run here. We can say, oh, okay, let's make a party animal, Sally. And so that constructs an object like this and then stores that in S. And with an X starting out 0. And then we call S party. Oops, better change that color. Starts out at 0, and then we call the party method, and that changes it to 1. Okay, and so this bit of code, it's as if this part doesn't matter at all because it is a party animal. It's not a football fan. But now, if we take a look at this code down here, take this code down here, we're going to construct a football fan and pass in Jim. But football fan has no underscore init, so that actually uses the underscore init from party animal because we extended party animal to make football fan. So we inherited all of the good that was in there. So there it's going to make a name, a variable X, which is going to start at 0, a variable name that's going to have Jim in it, and a variable points that's going to have a 0 in it. So this J variable has more things in it than the S variable has. And so we could call the J
Football fan Jimmy. It has class. It extends all from party animal, and it extends an additional all the methods. Okay.
party. And if we call J party, that goes here and adds 1 to X, right? So that adds 1 to X. And then we call J touchdown. Well, that comes down in here and adds 7 to the points, right? And then calls party within us. And so self.party is a current object, i.e. self and J are the same thing, right? Self.party. And then it goes up here and passes self in, and it adds 1 to the X, in this case, of this J variable. So this becomes 2. And that's where it prints out, 7 and 2, and away you go. And so it's a way for you to kind of take all this stuff and stuff it into a class by making a new class and just add the extending bits, the bits that are in addition to the other stuff. So like I said, inheritance is a powerful and wonderful concept. It's a form of excellent form of reuse, but basically The whole purpose of this lecture was so that I could in the future just use these words and you would understand them as compared to, I just want to say method. And I've been saying method all along. It's high time that I defined it. So let's just review one last time. Class is a template. It is not actually a thing. It is a shape of a thing. And we define it and say, when we make one of these things, it's going to have these variables in it. It's going to have these methods in it. Attributes, variables within a class.
Te amo. Mucho te amo.
Object is once we construct a class, we get back an object. And so object here is the snowman cookies. Class is the snowman cookie cutter. And a constructor is a bit of code that sets up our object, our instance, when it first is created. An inheritance is this ability to create a new class, but take all and import and affect all the capabilities of an existing class. So,
this very structured approach to code reuse, we can group data and functionality together and create many independent instances of a class. Quiero copiarlo entonces. Entonces, vamos a hacer otra práctica. Free Code Camp YouTube. Ok, entonces tenemos una clase, algo en minúscula, que vamos a llamar Party Animal. Vamos a leer código y irlo escribiendo. Empieza con mayúscula cada nueva palabra. Party Animal. Ok, listo. Después X variable, le vamos a asignar un atributo que va a ser X igual a 0. Le vamos a asignar otro atributo que va a ser nombre, que lo vamos a empezar en vacío. Esto no tiene que tener puntos, listo. Vamos a llamar a su constructor que es init. Ok, le vamos a pasar self y name. Uy, yo creo que el man se equivocó. Bueno, no pasa nada. Entonces, en vez de set de pass, que automáticamente lo puso nuestro editor de código, le vamos a poner self.name. Self.name igual a name. Listo. O sea, nuestro constructor va a llamar al nombre y adicional a eso me va a imprimir lo siguiente. Me va a imprimir self.name igual a constructed. O sea, me va a imprimir el nombre. Y va a decir construido. Ahora, vamos a agregar otra función, otro método a nuestra clase, que va a ser party self. Ok, listo. Entonces, damos espacio y aquí vamos a poner self.x igual a self.x más 1. Print self.name. Entonces nos va a imprimir el nombre. ¿Por qué no se escribe bien? Porque escribo adelantado. Self-name, coma, party account, count, self point x. Listo. Okay, we have defined the class. Okay. Now, what we are gonna do is to create a new class, but this is gonna be different to the other. Why? Because that is the idea of inheritance. Party, it's gonna extend all the attributes, and it's going to animal, and it's going to, and we are gonna add more attributes and methods. So point, for example, points, it's a new attribute that we are going to add to class football, and we are going to add a new method that we are gonna call touchdown, okay, and it's gonna call self. It's always self. It has to be okay. uh, Moreover, we have to add the constructor self points. But my question is why we have to add a, and that's something that we are going to ask to ChatGPT. We have to put a self inside of the class that we are creating. In Python, self parameter is a parameter is used inside a class methods to refer the instance that refers to instance. Okay, refer to instance of the class that is calling the method. It allows you to access and modify the instance attributes and methods. It represents instance itself. It represents instance. It differentiates instance variables from local variables. Without self, Python wouldn't know whatever a variable belongs to the instance, or just a regular local variable inside the method. It enables multiple objects to have different values. Each instance of class has its own self, allowing different objects to have unique data. Okay, it helps us to the keyword here is to reference to the instance, reference its own attributes. It referred to the instance. The methods parameter is used inside the class methods to refer to the instance of the class, So it helps us that every time that we create a class or a subclass, that we create an object that is extended from a class, it creates automatically and its own attributes and its own methods. Okay, self points, it's equal to self point points plus 7, and we have another refers to extend result point party. Okay, we created a new subclass extended from party animal. It means that we are going to have the same attributes and methods from party animal. Moreover, we have created their own methods. Okay, def touchdown self party, and print 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 self point point name points comma self points. Okay, now we are going to call the create the objects according to the class. Aquí vamos a imprimir un print free code count class. La tengo en mayúscula. Okay. So we're going to create this example that he provided to us. He provided to us. Okay. So S equal to party animal that we are going to call Soli. Okay. N is point party and we call the constructor. So that's gonna print Soli constructor Soli party count 1. Why? Here is self-constructed, that is Soli, and additional party count self. Self party. Okay. But I wanted to know how we can to check the argument. So we can print with dict. And the key is print with the to check the arguments. Car Toyota. Car Toyota. To check. Try something different, no? Name Soli x equal to 1. And to check the methods, to check the arguments, adding function after being created a module, adding a function after. Car Toyota. Without a module. S point 200 Car Toyota. But automatically we have to put func method. No, that is for adding after being created. Print. Ok, that's it, what it is. Ok, ahora vamos a crear el otro que va a ser y equal to football fan, and we are gonna call it Jimmy. So g.party stars g.touchdown, and we are going to print it with the method dir g dict. Listo, vamos a correr el código, ok. Entonces nos crea Jimmy Party Count 1, nos crea Soli A, Soli constructor, Soli party count 1 nos muestra que Soli quedó agregada con el nombre pues, Soli con la variable x en 1. Jimmy constructor fue construido Jimmy, party count 1. Jimmy party count 2 porque hereda el del primero. Y hereda el del segundo. El del segundo. Y adicional a eso, pues se agrega diferentes puntos. Otra función que es points. Y ahí quedaría self points más 7. Entonces quedaría name, x y points 7. Entonces eso es inheritance. Bueno, acabamos. Ya nos vemos dentro de 5 minutos. Entendimos inheritance gracias a este calvito hermoso. Lo amo, precioso. Ya nos vemos dentro de 5 minutos.